Related rates. These are problems that allow us to deal with equations containing variables that change over time. While there are many different types of related rates problems, there's a similar strategy to solving each one. So we're going to look at that strategy as we go through these problems. The strategy for solving related rates, we have about 6 steps. The first step would be to understand the problem. Identify the variable whose rate you seek and the variables whose rate of change you already know. Step 2, develop a mathematical model of the problem. So draw a picture, label the quantities, and be careful to note which quantities are constant, meaning they don't change, and which will change over time, because that's important. The rate of change of a constant quantity will be 0, and will, that's important to know in the problem as we're substituting. So just pay attention to that. Step 3, write an equation relating to the variable whose rate of change you seek with the variables whose rate of change you know. So some of the formulas will be given to you, but some you may have to recall or construct. So, things like the volumes of cones and spheres, usually you'll be given those, but when it comes down to, area, volume of rectangular prisms, area of triangles, and areas of circles, some of those things and you're going to have to be able to recall those. If you need, especially during homework and classwork, both of your calculus books have lists of common formulas. The blue book, it's in the front cover, I think. The orange book, it's in one of the appendices. So you can use those. And if you're at home or have access to the internet, of course, you can always Google. Step 4, differentiate both sides of the equation implicitly with respect to time. So we are going to be using implicit differentiation for these problems, and it will be something that we do every time, always with respect to time. Okay, and then be careful to use the chain rule and product rule when needed. There are several formulas that we use pretty frequently, and they contain a product, and a lot of people forget to use the product rule. So be real careful with that. Step 5, substitute values for the known quantities and known rates of change. You may have to do calculations to get some of these known quantities, ratios and proportions, especially with cone problems. They like to not give you quite all of the quantities explicitly, and you end up having to use ratios to solve those. But we'll look at some examples of those in a day or two. The only variable left in your equation after you substitute everything you know should be that quantity or that rate that you're trying to find. So, usually everything ends up substituting out except the one thing you're trying to find. So you want to keep that in mind. Find the solution. Step 6, find the solution and interpret the results. You want to check and make sure your solution makes sense. Is it okay that I got a negative number? What does that mean in terms of the problem? And don't forget your units. Most of these are going to have units, and you want to make sure that you've got those in there, especially on the AP exam. You don't lose points, and you'll definitely lose points on my exam, so be careful with that. All right. When you're done copying all those steps, you may have to go back, rewind, pause, all of that. Then I'm going to show you our first example. All right, here we go. Example number 1. Suppose x and y are both differentiable functions of t and are related by the equation y equals x squared plus 3. Find dy dt when x equals 1, given that dx dt equals 2 when x equals 1. So the first thing that we want to look at is what is it that we're trying to find. And we are being asked to find dy dt. We are going to take the derivative of the given equation, but we're going to take it not with respect to x, but with respect to t, which is time. And related rates, this is what we do. We do it with respect to time. So we're given that x equals 1, and we're also given that dx dt equals 2. So what does that mean? Dy dt is simply saying that as time goes on, how is y changing? And dx dt is telling us that the x value is changing at a rate of 2 with relationship to units of time. So again, it's just all related back to time. As time goes on, for every unit of time, y is changing, or find how y is changing when x is changing at a rate of 2 units, and at the point that x equals 1. Okay, so our strategy tells us that once we get everything quantified, and we have already, this is one where we've already been given the variables y and x, then we are to take the derivative, right? We know what we're trying to find, and we know when we're going to find it. X equals 1, dx dt equals 2. So we're going to take our derivative. So y equals x squared plus 3. So dy dt equals 2x dx dt plus 0, technically, because the derivative of 3 is 0. Okay, we've taken the derivative of both sides with respect to t, so now we're going to substitute in. So we don't know what dy dt is, that's what we're trying to find. But what we do know is that x equals 1, and the rate of change of x with respect to time is 2, because those were given to us. So dy dt equals 4. This is telling us that for every unit of time, at x equals 1, when x is changing at a rate of 2 units per unit of time, dy dt will be changing at a rate of 4 units per unit of time. So y will be growing faster than x. We know that both of those values are increasing because their derivative values are positive. So x is getting bigger and y is getting bigger. And since dy dt is 4, when dx dt is 2, y will be getting bigger faster. So we know this is an increasing function, and y is growing faster than x is. There's no units to this problem. We weren't told what time is, and these are just y and x values. It's possible that they could give us some with, centimeters, inches, things like that, but not in this particular problem. Okay, so that's how we're going to do these problems. Tomorrow you're going to have several problems like this. You'll be given different pieces of information. You may be given what y equals. You may be given what dy is, and then you happen to find dx dt or something like that. So just read the givens carefully in the problems, and you're going to be working problems 1 through 10 on page, well, I don't remember what the page is. I think it was 146, but I'm not sure. So just look on Blackboard and you'll get the page number. All right, see you in the morning.